class completed. So once again we are discussing the chapter number system. This is the basic chapter of mathematics. So in number system, some numbers are grouped into group, and we named the numbers are grouped and we named some names. So based on these groups, the number system are divided into two types: real numbers,
complex numbers.
Complex numbers.
and complex numbers. This real numbers is again divided into two types:
Rational numbers,
Rational
irrational numbers.
and irrational numbers.
rational numbers and irrational numbers. Again, this rational numbers is again divided into three types. That is
Whole numbers,
Natural numbers, whole numbers, integers.
whole numbers, integers. Whole numbers, natural numbers,
right. Whole numbers, integers. Integers. So right. Right. This is natural numbers. So coming to sorry. So rational numbers. In rational numbers, what is meant by natural numbers? So the natural numbers is denoted by capital N.
capital N.
The numbers are starting from 1,
1,
2,
2,
3
3,
and infinity. So these numbers are, so at that time the 0 is not included in natural numbers. So the numbers are starting from 1, 2, 3 and infinity. This group of numbers is called natural numbers.
Natural numbers.
So when we include 0 to the natural numbers, that numbers are called whole numbers. Whole numbers is denoted by capital W. Capital W, that is equal to 0, 1, 2, 3 and so on. Up to infinity. So the group of these numbers is called whole number. Whole numbers. So coming to integers. Integers is denoted by integers are denoted by Z or I. So these numbers are, the group of these numbers are minus infinity to minus 1, 0, 1, 2 and plus infinity. The group of these numbers are called integers. These numbers minus infinity to plus infinity. So these numbers are called integers. And only positive numbers are called Z plus. This is denoted by Z plus. Only these numbers. These numbers are denoted by 1, 2, 3. 1, 2, 3 Z plus. This is Z minus. This is denoted by Z minus.
Sir, what about 0? Sir, what about the 0?
The definition of integers are positive numbers, negative numbers and 0. The combination of negative numbers and positive numbers and 0. The 0 is neither positive nor negative. Positive or negative or. So that's why the combination of negative numbers and positive numbers and 0 is called integers. This positive numbers is called Z plus. Negative integers are called Z minus. Just denotion. Total integers are denoted by Z or I. So coming to rational numbers. Rational number is a number in which a number is in the form of P by Q,
In which Q is not equal to 0.
or Q is not equal to 0. P and Q are integers.
If P and Q are natural numbers, then
It is a fraction. Very good, Nana. A number if a number is in the form of p by q, q is not equal to 0, p and q are natural numbers, that p by q number is called a fraction. P by q, q is not equal to 0, p and q are natural numbers. Natural numbers, then it is a fraction.
Fraction.
Fraction. So this is the difference between main difference between fraction and a rational number. Fraction and a rational number. A rational number p by q, q is not equal to 0, p and q are integers. P and q are integers, then this number p by q, this number is called rational number. Rational number. Right.
Sir, and every rational number, every fraction is a rational number, but every rational number is
Yep.
not a fraction.
Right, very good. Correct. Minus 1 by 2. Minus 1 by 2 is a rational number, but not a fraction. 1 by 3, 1 by 4 are total are fractions and rational numbers. So every fraction is a rational number, but every rational number is not a fraction. Right. Coming to irrational numbers. A number which is not in the form of p by q.
by Q form.
Not in the form of
P
in
by
the form of
P by Q.
P by
not in the form of p by q is called irrational number. So that means a number that అంటే ఎప్పుడు కూడా p by q form లో ఉండకూడదు. This is nothing but to explain this correctly, we want to know the types of rational numbers. సో అది అర్థమైతే మీకు అర్థం 8th క్లాస్లో వస్తుంది అన్న. 8th క్లాస్లో వస్తుంది. ఏంటిది అది? రికరింగ్ డెసిమల్ అండ్ నాన్ రికరింగ్ డెసిమల్స్. సో ఇప్పుడు మీకు అది రాలేదు కాబట్టి ఓకే, ఎగ్జాంపుల్స్ చెప్తాను. జస్ట్ ఐ విల్ ఎక్స్ప్లెయిన్ ద రేషనల్ నెంబర్స్ ఎగ్జాంపుల్స్. టోటల్ కాన్సెప్ట్ చేయాలంటే మళ్ళీ యా టెల్ మీ అన్న జీ సాయి ఎగ్జాంపుల్స్ ఆఫ్ ఇర్రేషనల్ నెంబర్స్. ఎగ్జాంపుల్స్ ఆఫ్ ఇర్రేషనల్ నెంబర్స్.
Root 2, sir. Sir,
yes,
root 2.
root 2, root 5, root 7 or root 3, root 3, root 5, root 7, root 11. సో రూట్ల వాల్యూస్ లేని మొత్తం ఎగ్జాంపుల్స్ ఆఫ్ ద ఇర్రేషనల్ నెంబర్స్.
prime numbers. Sir, roots of prime numbers.
Not prime numbers, not exactly. Root 18 is also a irrational number. Root 18 can be written as 3 root 2. Root 18 nana. Root 18. Root 18 is written as root 9 into 2. Sorry, root 9 into 2. That is root 9 into root 2. That is 3 root 2. 3 root 2 is also a irrational number. 3 root is also irrational number. Tell me Nana.
3 root 2 అంటే 3 by 2 కాదు కదా సార్?
కాదు నాన్న. Is it the value of root 2 is 1.4143 something is there, so much big. It's non-recurring decimal means nana. Irrational is different. Okay, so I will explain shortly. 1.4143257897. This repeating and it never stops. It never stops and it never repeats. It never repeats. For example, for example, what is the value of? I am telling the example of rational number. See, for example, 20 by 3. What is the value of 20 by 3 in decimals? What is the value of 20 by 3 decimals, Nana? Tell me. So that is 23.
6.6666.
Right. 18.2.0. Right, Nana? Again 6. 20. Sir, 18, 2, again 6, 20, 18. So it's repeating. It's repeating. What is the answer? 6.6 bar. 6.6 bar. So this is not a rational number. Here one some repeating pattern is there. This is repeating pattern is there. This is a recurring decimal. This is called recurring decimal. So 20 by 3 is a rational number.
Rational number.
It's a rational number. 20 by 3 is a rational number. If the decimal part is repeating or some pattern or for example 1.123 123 123 123 just like repeating, this is also not a rational number. This is also a rational number. This is not a irrational number. This is a rational number. 1.123 123 1.123 or 1.123456 123456 123456 just like repeating. It's some pattern. That number is a rational number.
Numbers.
If it is the decimal part is following not following certain patterns or not repeating some numbers, that number is called irrational number. I think you are clear.
Yes, sir.
Vasini?
Sir.
Yes, Nana, tell me.
Sir, not really, but fine, sir. I think
Yeah,
I
G Sai
learn
clear.
in higher classes.
So, okay. First, you want to know the recurring decimal, non-recurring decimal, terminating decimal, non-terminating decimal. So, first, you want to know the rational number correctly. Then, we will exactly know the definition of the irrational number. I think somewhat clear. What about what is irrational number? Irrational number means like this. The decimal part is not repeating with some patterns. So here 20 by 3 is a rational number. This is non-terminating decimal. Non-terminating decimal, and it's not terminating. It is not stopping. 6.66666 not stopping. If you do 1000 times, it never ends. So this is a non-terminating decimal. If it stops, it's a terminating decimal. Recurring decimal means it's some pattern. This is a recurring decimal. Non-terminating and recurring decimal. If it is non-terminating and non-recurring decimal, then it is a irrational number. Then it is irrational number. Are you clear? First, you want to know the terminating and non-recurring, non-terminating. Terminating means while it stops, the decimal part will stops. Non-terminating means doesn't stops. Recurring means with some repeating with some pattern. Non-recurring means there is no pattern, such patterns. So non-terminating and non-recurring decimal numbers are irrational numbers. Yeah, clear?
Yes, sir.
Yeah. So okay. So real numbers is 10th class chapter. Now okay, let's leave it. Right. The combination of rational and irrational is real numbers. That is this rational numbers and irrational number. The combination of these two numbers is called real numbers. So right. So now we will discuss properties. Yeah, some messages came from the coordinator. What is that message? Hi everyone, good evening. Next class 6:45. Nana. Next class 6:45 p.m. physics class. Please join. Already I send link in group. Nana, physics class is 6:45. Link is came. All students, 6th and 7th classes. Right, Nana? Physics class, some sir is taking. The class starts 6:45. So actually our time is 6:50. So we will end before 5 minutes for the physics class. Okay, Nana?
Sir? Sir?
Yeah, see, listen. Yeah, tell me, Nana. Tell me. Some who called sir. Yeah. Okay. Now the introduction class. Yeah, tell me, Nana.
Sir, physics next class is for all the classes.
6th and 7th, Nana. The lengthy coordinator madam is some message is in chat box. So you will join
sir,
6:45. 6:45. Okay, Nana. See. So up to rational number, up to real numbers we completed. The definition of
Sir,
So please
Sir?
tell the natural numbers. Tell me, Nana.
Sir, will you explain again, sir?
Explain again. Who is that,
Again,
Nana?
Hyperhanan, sir.
Nana, you joined late. Which class, Nana? 6th class or 7th class?
Sir, today annual exams are completed. I promoted to 7th, sir.
Promoted 6th class completed. So okay.
Sir.
So 7th class. Tomorrow you will join, Nana. రేపు తొందరగా జాయిన్ గా మళ్ళీ ఎక్స్ప్లెయిన్ చేస్తా. స్టార్టింగ్ క్లాస్ ఎక్స్ప్లెయిన్ చేసేసి చెప్తా, ఓకేనా?
Excuse me, sir. Sir, I am Pranav's mother. Hello.
మేడం, టెల్ మీ మేడం.
Sir, ఈ క్లాస్ ఎన్నింటి వరకు ఉంటుంది సార్? ఇది 6:40 వరకా సార్?
6:50 మేడం, 6:50.
ఓకే ఓకే సార్. అంటే యాక్చువల్లీ బాబు వచ్చి 7th కంప్లీట్ అయింది, 8th వచ్చాడు. ఒకసారి స్టాండర్డ్ చూడండి సార్. ఓకే అంటే ఇదే కంటిన్యూ, లేదంటే మారుద్దాం సార్, అట్లా అంతే.
మేడం, ఇది నాకు వీడియోస్ ఆన్ చేసుకోవాలి మేడం. వీడియోస్ ఆన్ చేసుకోవట్లేదు.
ఓకే సార్.
వీడియోస్ ఆన్ చేసుకుంటే నేను వాళ్ళ ఫేస్ అవపడింది. ఐ విల్ ఆస్క్ సమ్ క్వశ్చన్స్ అడిగేసేసి నేను చెక్ చేయగలుగుతాను.
ఓకే సార్. ఓకే సార్.
ఇంటరాక్షన్ లేదు, ప్రణవ్ అనేది ఇంతవరకు ఇంటరాక్షన్ లేదు. కొంచెం నాకు ఇంటరాక్షన్ అవుతా ఉంటే నేను చెక్ చేస్తా ఉంటాను స్టాండర్డ్స్. వీడియోస్ కంపల్సరీ ఆన్ అయి ఉండాలి.
నేను ప్రణవ్
నేను అడిగినప్పుడు చెప్తా ఉండాలి, అంతే.
ఓకే సార్. ఓకే సార్. సార్
అదొకటి
ఇంకొకటి
చెప్పండి.
ఫిజిక్స్ కెమిస్ట్రీ అని కూడా చెప్పారు సార్. అది ఏ టైంకి ఉంటుంది సార్? అది
యాక్చువల్గా కొంచెం ఫంక్షన్కి వెళ్ళేసేసి కొంచెం వేరే ప్రాబ్లం ఉన్నారు సార్. ఒక 2 days లో మళ్ళీ జాయిన్ అవుతారు. ఈ రోజు మాత్రం 6:45 ఉంది క్లాస్ ఫిజిక్స్.
ఓకే ఓకే
6:45 ఉంది, మీరు జాయిన్ అవుతుంది. ఇప్పుడు క్లాస్ అయిపోగానే వెంటనే ఫిజిక్స్ క్లాస్ ఉంది.
ఓకే సార్. ఓకే సార్.
ఓకే. Yes, see, Nana. The properties. Right? Closure property. The properties are closure property,
Commutative property, associative property, commutative property, associative property.
right? Commutative property.
Associative property,
Yes. Associative property.
distributive inverse, multiplicative inverse, additive identity, multiplicative identity.
Right. Distributive property.
Additive and multiplicative identity.
Additive identity.
Multiplicative identity, additive inverse, or multiplicative inverse.
Additive inverse.
Additive inverse,
Multiplicative inverse.
multiplicative identity, multiplicative inverse. Zero property.
Multiplicative identity.
Multiplicative inverse.
Multiplicative inverse.
Sir, and also zero property.
Yeah, Nana? Tell me.
There is zero property for whole numbers.
Right. So next. See, Nana. First, we discuss about these properties, and these properties want to apply for natural numbers, for whole numbers for 6th class. Natural numbers and whole numbers for 6th class. Integers for 7th class. Rational numbers for 8th class. This is the concept. So first we want to know about the properties. So closure property. Do you know the closure property?
Sir, if we did addition, we have to get the answer in whole natural numbers or whole numbers.
Right. That number, that is called closure property. If you add or subtract or multiply or division, we want to get that number only. If we take natural numbers, we want to get natural number. If we get whole numbers, we want to get whole numbers. If we take integers, we want to get the integers. If we get that number, then this property will satisfy on that number. So today we will complete.
Sir, for example.
So today we will complete. First we will see. So example. So today we will see about natural numbers. Natural numbers and whole numbers. We will see both. Yes, we will see both. For natural numbers, addition, Nana. Addition, closure property. If we examples of two natural numbers, 2 and 2. or 2 and 3 or 4 and 5, 4 and 4. Same also the natural numbers. 2 plus 2 is 4. Under addition.
Yes, sir.
Addition, subtraction into division. Addition, subtraction into division. So let's see. In addition, if we add two natural numbers, we will get a natural number or whole number?
Natural.
Natural number. So this closure property satisfies under addition. This closure property satisfies under addition. So coming to subtraction. If we subtract two numbers, we will get natural number or not?
Sir, sometimes natural number, sometimes whole number.
Sometimes whole number. Sometimes integers also. Sometimes integers also.
Yes, sir, sometimes integers.
Sometimes integers also. So tell me.
Sir, now this plus 2 minus 2 it will satisfy for whole numbers, not for natural numbers.
So right. So this closure property doesn't satisfy under subtraction. Yeah. Coming to multiplication. If we multiply two natural numbers, we will get natural number or not?
Yes, sir.
Yes. So this is also closure property satisfies under multiplication for natural numbers. Coming to division. Yeah.
Closure property satisfies.
Under division.
If any number multiplied with 0, then it will be 0 when it is whole number, right, sir?
Nana, your voice is slow, Nana, very low.
Sir, if any numbers multiplied with 0, it will be a whole number, right, sir?
Nana, voice is breaking and very low.
Sometimes whole number, sometimes natural number.
Wow, which Nana? I didn't understand. Sai Kankshit? Sir, tell me, Nana, what is he telling? Tell me, Nana.
Sir, she's saying that satisfy.
Satisfy division. Division satisfies not, Nana.
Sir,
It's
yes,
Nana.
sir. 1 divided by 5 is 0.2, no, sir.
So it is not a natural number. So it doesn't satisfy.
Yes,
If
sir.
we divide two numbers, we didn't get a natural number. Example 1 and 2. 1 divided by 2. So we didn't get a natural number. Nana?
Sir, but in this case, 2 by 2, we will get 1 and 1 is a natural number.
Nana, for every number, it want to satisfy. For every number. If you take any example, if it satisfies, then it satisfies only. If some number satisfies and some number didn't satisfy, it is wrong. Okay, Nana? So, under division, it is not satisfies. Closure property is not satisfies under division for natural numbers. So, coming to whole numbers. Closure property for addition. Tell me, Nana. Closure property for addition satisfies.
Yes, sir.
Minus subtraction.
No, sir.
It's not satisfies. For subtraction, not satisfies. Example 3 minus 5. 3 is a whole number, 5 is a whole number, 3 minus 5. Minus 2. Minus 2 is not a whole number. So it doesn't satisfy under subtraction. So coming to multiplication. If we two numbers multiply, the answer is a whole number.
True, sir.
Satisfies. So coming to division. Not satisfies. Same example, 1 divided by 2. Yeah. Coming to commutative property. Now, commutative property means if two numbers, if the two numbers are let the two numbers are A and B. If the two numbers are A and B, for commutative property, A plus B is equal to B plus A.
B plus A.
B plus A. If this for under addition, subtraction means A minus B is equal to B
B
minus
is
A.
equal to B minus A.
Multiplication, A into B is equal to
Same,
B into
same.
A. For division, A divided by B is equal to B divided by A. This is the commutative property under addition, under subtraction, under multiplication, under division.
Sir, I have a doubt.
Tell me, Nana.
Sir, how A minus B is equal to B minus A, sir? A is a different value and B is a different value.
So, Nana, 0, 0. A and B are 0. If 0, Nana, these are the. ఇది సాటిస్ఫై కాదంటే ఈక్వల్ అయిద్దా కాదా అని ఐఎమ్ నాట్ సేయింగ్ సో ఇలా అయితే ఇప్పుడు మనకి సాటిస్ఫై అని రాస్తాం ఇక్కడ అర్థమవుతుందా
Sir, same result.
if the results are same nana అన్ని ఈక్వల్ వస్తే ఇలా if it comes equal under addition and subtraction and multiplication and division then all will satisfies so we want to check whether satisfies or not. If it is equal to it satisfies, if it is not equal to it doesn't satisfies. So we will check for natural numbers and whole numbers. So coming to natural numbers, commutative property under addition, take two numbers 1 comma 2, 1 plus 2 answer is 3, 2 plus 1 answer is also 3. Take any example and check. So the commutative property will satisfy under addition. Yeah, Nana, clear Nana?
Yes, sir.
So coming to subtraction,
Sir,
the two
doesn't
numbers.
work.
So okay. So we will take 1 and 2. Same example. 1 and 2. 1 minus 2 is equal to minus 1. 2 minus 1 is equal to 1. So minus 1 is not equal to 1. So commutative property under subtraction doesn't satisfy.
The commutative property on natural number and whole number subtraction. If the two numbers are same, only it will satisfy you.
Right. Only it satisfies. So right, Nana, Pranav, are you following? Pranav.
Yes, sir.
So tell me what about multiplication? Nana.
Satisfies.
Only Pranav. What about the commutative property under multiplication?
It can satisfy, sir.
It can satisfy. Vrishank, I asked to Pranav.
Sir, I didn't told you.
Okay.
I only told, sir.
You only told, right?
Sir.
So it satisfies. It satisfies under multiplication. Take any example. It will satisfy under commutative property. 2 into 3, 3 into 2. The answer is same. So commutative property satisfies under multiplication for natural numbers. So right. So coming to division. See, A by B is equal to B by A. Tell me, it satisfies or doesn't satisfies?
Not work, sir. Does not
Not
work.
doesn't satisfies.
Doesn't satisfy.
Doesn't satisfies. Yeah, same as whole numbers also. Now I am writing fast. If any doubt, ask. For addition, whole number satisfies. Commutative property. Subtraction not satisfies. Multiplication satisfies. And division doesn't satisfies. Yeah, clear, Nana?
Sir,
For seventh class, these properties we want to applicable for integers. This class is for 6th class. For 7th class, we want to applicable for integers. Yeah. Coming to associative property. This property is based on 3 numbers. That is, let the 3 numbers are. A comma B comma C. So the property of associative property is under addition A plus of B plus C is equal to A plus B plus C.
Is equals to
Yeah, no. See, this is the associative property. So in this property, first, this is under addition. First, we want to add these two numbers. The bracket, Bodmas rule, BODMS Bodmas rule. So first, we want to simplify the in brackets, simplified in brackets. So this we want to add these two numbers, and the answer is added to this number. This is one answer, and for this, these two numbers will added first, and the answer result is added to this number. This will answer. If these two answers are same, then associative property satisfies under addition for natural numbers. For multiplication, a into b into c is equal to a into b into c minus a minus of b minus c is equal to a minus b minus c. This is a subtraction. So division, a divided by b divided by c is equal to a divided by b divided by c. So first we want to divide these two numbers. The answer is divided by this number. So same, these two numbers. First we want to divide these two numbers, and the answer is divided by this number. If these two answers are same, then it is satisfies under division. So let we will check for natural numbers and whole numbers. So coming to natural numbers for addition. Yeah, see, for addition, take for example, take example. I could add the example. Tell me three numbers. 1, 2, 3. 1, 2, 3. 1, comma 2, comma 3. So 1 plus 2. Okay, plus
Addition.
1 plus 2 is equal to 1 plus 2 plus 3.
Satisfies.
Yes, satisfies. 2 plus 3 is 5. 5 plus 1, 6. 1 plus 2 is 3. 3 plus 3 is 6.
3, 6.
So it satisfies. Satisfies under addition. Satisfies under addition. So associative property is satisfies under addition for natural number. Same as whole numbers also it will satisfies. Whole numbers also satisfies. Yeah. Coming to subtraction. So coming to subtraction, the same numbers we will take. Same numbers 1, comma 2, comma 3. So 1 minus 2 minus 3. 1 minus 2 minus 3 is equal to 1 minus 2 minus 3. So here see, 2 minus 3 is minus 1, minus of minus plus. So 1 plus 1,
No, sir.
2. Again 1 minus 2 is minus 1, minus 1, minus 1, minus 3, minus 4. It's not equal.
Not
2 is not equal to minus 4.
Sir,
Then,
multiplication it satisfies, sir.
so right. So right. Yeah. Coming to multiplication.
Satisfies.
Satisfies. Same example 1, comma 2, comma 3. 1 into 2 into 3 is
2
equal to
into
1 into 2
3,
into
6.
3. 2 into 3 is 6. 6 into 1, 6. 1 into 2 is 2. 2 into 3 is 6.
2
6
into
is
3,
equal
6.
to 6. Then associative, same as whole numbers also. Associative
Sir,
property
division.
satisfies under multiplication for natural numbers and whole numbers. Tell me, Nana.
Sir, in division it does not satisfy, sir.
Right. In division, it doesn't satisfy. Division, it doesn't satisfy. Division, that doesn't satisfy. Yeah, clear, Nana? So, tomorrow we will discuss about distributive property, additive identity, additive inverse, multiplicative identity, multiplicative inverse. Now you have a class. That's why I'm ending right now. So 6:45 అన్న. So the time is 6:40 అయింది. 6:45కి మీకు ఫిజిక్స్ క్లాస్ ఇప్పుడు రెడీ అవుతుంది. గ్రూప్లో మెసేజ్ పెట్టారు కాబట్టి దట్స్ వై ఐఎమ్ లీవింగ్ అన్నా. ఓకేనా? సో టుమారో రేపు ఒక్కరోజేనా, రేపు ఒక్కరోజే మీకు కంబైన్ క్లాస్ ఉండేది. ఎల్లుండి నుంచి వి విల్ సపరేట్ 6th and 7th. షూర్. సో రైట్ నానా. సో ఒక్క 5 minutes అంతే, 5 minutes బ్రేక్ తీసుకొని వచ్చేసేయండి. సో విల్ స్టార్ట్ ఫిజిక్స్ క్లాస్. సమ్ అదర్ టీచర్, నాట్ మీ, సమ్ అదర్ టీచర్ విల్ స్టార్ట్ ఫిజిక్స్ క్లాస్ విత్ ఇన్ 5 minutes. 6:45 sharp, 6:45 విల్ స్టార్ట్. సో ఓకేనా?
Okay, sir.
సో రైట్ నాన్న, రైట్, థ్యాంక్ యూ.
Thank you, sir. Bye, sir.
బాయ్ నాన్న.
Bye, sir.
యా బాయ్ నాన్న.
Bye, sir.
బాయ్.